Alright, in this first coding lecture, we will import historical prices for the Dow Jones Index that we pulled earlier from Yahoo Finance and that we saved in the CSV file Dow Jones Index.csv. So first of all, let's import pandas. And then we can import the CSV file with read CSV. And let's have a look at some meta information here. And here we can see that we have still the data type object in the date column. So essentially we have text here. And by default, Pandas is actually not able to identify and convert text data that contains datetime information to the data type datetime. And therefore we have to use the pass dates parameter. And here we have to pass a list with those column labels that you want to convert into datetime. So in this example, the date column. And actually, if we work with financial data, it definitely makes sense to have the date time column as the index to actually have the best possible functionality of our data frame. And therefore, we also pass date to the index call parameter. And then we save the resulting data frame in data. So that's data here with a datetime index on the left-hand side. So we have entries from beginning of 2007 until end of March 2020. And finally, for our purposes here, we are interested in the roundabout 10-year period from 2010 till end of March 2020. So we will see in the next lecture that this period contains more or less one business cycle. So we have starting in 2010, the bull market after the financial crisis. And actually, we also have included the dramatic fall in prices due to the corona or COVID-19 crisis. So we are selecting the rows or the data points in this period, and we are only interested in daily close prices. And by doing so, we would actually create a panda series, but it might be better to work with a data frame with one column. And therefore, we convert the series to frame, and we create the data frame df. So that's the data frame that we are working with in the next lectures. So we have the daily close prices for the Dow Jones Index from 2010 till end of March 2020. All right, thanks for watching, and see you in the next lecture. Bye. Hi and welcome back. Before we are going to backtest some simple strategies in the next lectures, this is a short lecture on analyzing and visualizing our price data, and also we will further process the data and calculate daily returns based on daily prices. So we have still saved the data frame df, and we have imported pandas, and in addition we also import matplotlib, numpy, and seaborn, and we use the seaborn style. And first of all, we can further analyze the data frame df by getting some summary statistics with describe. And for instance, here we have the average or the mean price over the period, or we can also see the minimum price or the maximum price. And we can also visualize and plot the price over time with a line plot. So actually, we simply use the plot method here, and we want to have a figure size of 2012. And we also enable the legend. So that's here the Dow Jones Industrial Average Index from 2010 till end of March 2020. And actually, after the financial crisis, we have here a very long-term bull market. So from 2010 till 2020 in February or March. And then in March 2020, we have here the dramatic drop due to COVID-19 or corona. So it definitely makes sense to have this time period here, as we have kind of the full market cycle. So we have a bull market and also a crisis here. And next we can also calculate daily returns. So in finance, typically it's more meaningful to work with returns rather than absolute prices. So returns are actually the relative changes or percentage changes in prices. And we can simply calculate them with the percentage change method. And by doing so, we create the new column return. And let's have a look here. So here we have the daily returns. And for instance, here on the 24th of March 2020, we had a daily return of plus 11%. Then we had plus 2%, plus 6%, minus 4%. So due to the COVID-19 or Corona crisis, there was quite a lot of volatility in the market. And also it's no surprise that we have no return for the very first timestamp because we do not know the price of the previous timestamp. And therefore it makes sense to drop all rows where we have at least one missing value in one of these two columns. And we can do this with drop in A. So we're actually removing the timestamp 4th of January 2010. And now we can also plot prices and returns in one figure. And as the scales are very different, so the price is around 10,000 and the return is around 0, we have to create a secondary y-axis where we have the return. So that secondary y-axis will be on the right-hand side and the primary y-axis with the prices on the left-hand side of our figure. Now let's run the cell and let's have a look. So here in blue again, we have the close prices, so the daily close prices, and the corresponding y-axis here on the left-hand side. And in green, we have the returns that are actually oscillating around 0. And the corresponding y-axis here is on the right-hand side. And here we can see some volatility clusters. So it's no surprise that we have quite a huge volatility in the crisis here. And finally, let's tidy up our data frame and let's rename the column label. So instead of close, we want to have Dow Jones close prices, and instead of having return, the Dow Jones return. So later on, we will also add prices and returns for our strategies so that we want to backtest. And therefore, it should be clear that these are the Dow Jones prices and returns. So let's see our final data frame, and with this we will continue in the next lecture. So hope to see you there. Bye. In this lecture we will backtest a simple momentum strategy. But before we start coding, first of all I want to define some finance and investment terms that I will frequently use in the coding part. So essentially there are three different positions that I can take in a stock or in an index. So the simplest and most intuitive position is a long position. So when you buy a stock, you have a long position and you will win if prices rise, and you will lose if the prices fall. And in case of the Dow Jones index, you cannot directly buy the index, but you can buy a fund. So for instance, an ETF that is tracking the index. So essentially it's no problem to take a long position in the Dow Jones index. Next, the short position, or -1, is the opposite of the long position. And I don't want to go into the details of short selling, but essentially you will lose if prices rise and you will win if prices fall. And for some markets and for some securities, short selling is not permitted. So the assumption is here that derivative instruments are available that allow investors to take a short position in the Dow Jones index. And finally, we have the neutral position, or 0. So we simply do not have any position then here in the Dow Jones index. And so we have the long position +1, the short position -1, and no position 0. And now we want to compare two different strategies and actually backtest an active strategy based on the corresponding passive or basic strategy to find out whether the active strategy performs better than the passive strategy or not. And actually the basic strategy or the passive strategy is called buy and hold. So we initially invest into the Dow Jones index and then do nothing. So on each and every given day we have the position +1. And this is the reason why this is a passive strategy. So we do not take any actions or decisions once we have invested into the Dow Jones index. And then we have a simple momentum strategy that we want to backtest. So this is an active strategy because we take actions based on certain conditions. So we change the positions here. And the rule is pretty simple. So at the end of the day, if today's return was positive, then tomorrow we will invest and take a long position. And if today's return was negative, then tomorrow we will short sell the Dow Jones Index and take a short position. And this is called a momentum strategy because we assume that there's some momentum in the returns. This means that we expect that trends persist over a longer period. So for instance, if today's return is positive, then it's likely to have a positive return also tomorrow. And the same applies with negative returns. Now let's backtest this simple momentum strategy, and still we have DF with prices and returns. And now the plan is to create an additional column position that is based on today's returns, and that will indicate the position tomorrow. So for instance, here on the 5th of January, we have a negative return, and therefore the position should be -1, indicating that we short sell the index tomorrow. So coding-wise, we have to check for each and every element in the return column whether the element is positive or negative, and if it's negative, we want to have the value -1, and if it's positive, the value 1. And actually we can do this with np.sign. And actually np.sign determines the sign of the elements here. So either negative -1 or positive +1. And let's create the column position. And let's have a look here. So here on the 5th of January, we have a negative return, and therefore the position for tomorrow should be -1. Then on the 6th of January, we have a positive return, and therefore the position for the following day should be +1, and so on. And with this, we can create the additional column strategy return. So this is the daily return of our momentum strategy. And the intuition behind this is pretty simple. So we actually shift the position by 1 timestamp and then multiply with the return of the Dow Jones Index. Let's run the cell and let's have a look here. And for instance, on the 5th of January, we had a negative return, and therefore the position for the next day is -1. And on the next day, the actual return of the Dow Jones is positive, but the return of our strategy is negative because we actually had a short position on that day. Then now let's have a look at the next day. So on the 6th of January, the return was positive, and therefore also our position for the next day should be positive. And therefore the strategy return equals the return of the basic strategy, and so on. So now we have the daily returns of our strategy, and now we want to convert this into prices. So we want to compare the Dow Jones prices and the prices of our strategy, and also our strategy starts at a price of 10,572. And actually based on the strategy returns, we can calculate for each and every timestamp, so to say, the cumulative investment multiple. So first of all, we add 1 to each and every return. And if there's no return, like here in the first row, then the fill value is 0. And we actually calculate the cumulative product. So let's have a look here. And at the very first day, we have a multiple of 1. So the initial price or the initial value for our strategy should be the same as for the Dow Jones Index. Then at the next day, we have a multiple of 0.99 and so on. And finally, we can see in 2020 that obviously we lost value with the strategy. So we have a multiple of 0.47. And now we can simply convert the cumulative investment multiples here into prices by multiplying each and every element by the initial price of the Dow Jones Index, 10,572. So this is actually the code to get the very initial price. And let's create the additional column strategy where we get the prices for our strategy. So at the 5th of January 2010, we are starting at 10,572 for our basic strategy and for our momentum strategy. And obviously the prices for our momentum strategy declined over time. So at the end of March, we are left with 5,000. And compared to that, with our buy and hold strategy, we would have 22,000. And it definitely makes sense to visualize and compare both strategies. So we select the prices for the Dow Jones Index and our strategy. And here we have in blue the prices for the Dow Jones Index. So this is nothing new, simply buy and hold. And in green, the price chart for our momentum strategy. And it's pretty clear that our strategy underperforms the basic strategy. And finally, we can also calculate annualized risk and return for both strategies. So we can create here the function summary annualized. And first of all, we can aggregate and calculate the average or the mean daily return and the standard deviation of returns. And then we can actually multiply the mean daily return with 252. So typically we have 252 trading days in a year. And the risk we multiply actually with the square root of 252. So let's simply define the function here, and let's pass the returns of our two strategies to our user-defined function. And here we have actually the annualized return and the annualized risk. And essentially the risk is the same, but our strategy clearly underperformed in terms of return. So on an annualized basis, we have a return of -5%. And in the same period, the Dow Jones Index, so buy and hold, returned 8.7% per year. So the key finding is here that our simple momentum strategy clearly underperforms a basic buy and hold strategy. And therefore, we can conclude that this is not a beneficial long-term strategy. All right, thanks for watching, and see you also in the next lecture. Bye. In this lecture, we are going to backtest a simple contrarian strategy, which is essentially the opposite of a momentum strategy. So contrarian strategies are based on the assumption that trends do not persist over longer time periods. And in our simple case, this means that positive returns today will likely be followed by negative returns tomorrow and vice versa. And still we have our basic or passive strategy buy and hold. And the contrarian strategy can be defined as follows. So if today's return was positive, then tomorrow we will short sell the Dow Jones Index and have a position -1. And if today's return was negative, then tomorrow we will invest into the Dow Jones Index, so we have the position +1. But first of all, let's restore our data frame df. So we have still saved the original data that we imported from the CSV file. And with the following operations, we again create df. So here we have daily prices and daily returns between 2010 and the end of March 2020. And now there's only one minor difference between the previous strategies, so the momentum strategy and the contrarian strategy. So we add here a minus sign. And by doing so, we actually create the opposite positions than we had before. So let's have a look here. And for instance, on the 5th of January 2010, the Dow Jones index return was negative. And therefore, in the next day, we take a positive position, so we invest. And then on the 6th of January, we have a positive return. And therefore, in the next day, we will actually short sell the index and so on. And again, based on these strategy positions, we create these returns of the strategy. So this is nothing new. And the prices of the strategy. So let's visualize. And again, here in blue, we have the buy and hold strategy. And in green, our contrarian strategy. And also here, it seems that our strategy underperforms the passive strategy. At least this holds true for the long period here. But there are some sub-periods where our strategy performs better. So here, for example, or here, or also in the extreme crisis. But again, it seems that our contrarian strategy is not a profitable strategy over longer time periods. And let's also calculate the annualized risk and return. And again, the risk is pretty similar, but still the return is lower than buy and hold. So here we have 5.7% versus 8.7%. All right, thanks for watching, and see you also in the next lecture. Bye. All right, in this lecture, we will slightly adjust our code and create some more complex strategies. And we will try to find a strategy that outperforms our basic buy and hold strategy. And that's pretty much the most dangerous and most frequently made mistake in investing. Looking for patterns in historical or past data and search for a strategy that was profitable in the past based on that historical data. So this does not guarantee that the strategy will be successful in the future as well. And there's a clear difference between backtesting a strategy and fitting a strategy on historical prices. So whenever our strategy is not based on past data and not fitted on past data, it's okay to backtest that strategy. However, if the strategy is clearly fitted on past data by tweaking the parameters of the strategy until the strategy is profitable, this isn't backtesting, so it's fitting and it doesn't say anything about the future profitability. So in these cases, we have to test whether the strategy can generalize to new data, so to say future data, and we have to test whether the strategy still outperforms the basic strategy in the future. And this is called forward testing. And this concept is pretty similar to machine learning. So you cannot test an algorithm on the training set. You need fresh data, the test set. And first of all, let's again restore the data frame DF with prices and returns of the Dow Jones index. And then with the following code, we are more flexible. So again, we create the positions and we use actually np.where. And depending on whether a certain condition is met or not, we can define our position. So in this case, it's our simple contrarian strategy. So in case the return today is positive, so greater than 0, then tomorrow we will have the position -1, and otherwise we have the position 1. So that's the contrarian strategy. And let's again run the cells here. Let's check whether this is the contrarian strategy. And this is here obviously the case, so this is exactly the same. So this code here is more general and allows for additional flexibility. And let's assume that short selling of the Dow Jones index is not allowed. So in the best case, we can have here a neutral position. And we can also check this here. And still, most of the times, our simple contrarian strategy underperforms buy and hold. And now we could actually tweak the parameters here until we find a profitable strategy. And for instance, we could do the following. So it's not necessary to have here 0. Our condition could also be, for instance, that whenever the today's return is higher than, for instance, 1%, then tomorrow we will short sell the Dow Jones index. And if today's return is equal or lower than 1%, then we take tomorrow the long position. So let's backtest this here. And obviously this strategy clearly outperforms our buy and hold strategy. And the strategy here is intuitive. So a daily return of greater than 1% is pretty high. And whenever we have daily returns of more than 1%, then there are quite a lot of investors who just take the profits in the following day. And therefore, in the following day, we have a negative return. But nevertheless, I wouldn't call this here backtesting. So we have tweaked the parameters until we found a profitable strategy. And therefore, we shouldn't rely here on the backtest. So we should definitely also forward test that strategy. But this is beyond the scope of this project here. And finally, we can also annualize the risk and return for these strategies. So our new strategy has a return of 17.4% and clearly outperforms the buy and hold strategy. But again, even if a strategy seems to outperform the basic strategy, we should consider and analyze the following topics here. And again, there's a clear difference between backtesting and fitting. However, there's no clear black and white, and it's hard to distinguish. So to be on the safe side, we should also forward test a strategy. Then next, we have transaction costs. And whenever we change positions, this will trigger costs. And actually, we should include costs. But also, this is beyond the scope here. And finally, there are also tax effects. And changing positions can trigger additional or at least earlier tax payments. So we should also include taxes. Alright, thanks for watching and see you also in the next lecture. Bye. In this and the next lecture, we are going to backtest the strategies that are based on simple moving averages or short SMA. And these strategies are also called crossovers, and you will learn in a few minutes why. So moving average crossovers are a popular strategy for technical traders. And I'm really curious to see whether we can find any evidence that this strategy can outperform buy and hold. And actually, the rationale behind the moving average crossovers is that price trends persist over a longer time period. And essentially, it's a momentum strategy. But in contrast to our simple moving average strategies, where we considered the return of only one day to define the strategy for the next day, here we'll take into account the longer time periods and the longer price trends. So let's again create and restore the data frame DF with prices and returns, beginning in the year 2010. So that's the daily prices here. And now we can actually smoothen the prices by calculating moving averages. So for instance, we can calculate the average price for the immediately preceding 30 days or 50 days or whatever. And therefore, first of all, we have to define a rolling window, and we can do this with the rolling method. And actually, a very popular rolling window and simple moving average is the simple moving average 50. And actually, here we are taking into account the immediately preceding 50 trading days. So actually, for each and every timestamp, we calculate the average or the mean price for the immediately preceding 50 trading days. So that's the reason why we also chain here the mean method. Let's have a look here. And it's no surprise that for the first 49 days, we get missing values because here we do not have data for the immediately preceding 50 days. And for instance, let's have a look at end of March. So here we have 26,139, and that's the average price for the immediately preceding 50 trading days. So let's create the additional column SMA 50, and let's visualize the daily prices and the simple moving average 50 in one plot. And here in blue we have daily prices. And actually here we can see the effect of the simple moving average, so it actually smoothens the daily prices. Now let's come to another popular and frequently used window. It's the simple moving average 200, taking into account the immediately preceding 200 trading days. And let's also create the new column SMA 200. And finally, let's also visualize and compare the simple moving average 50 versus the simple moving average 200. And we can see here that the simple moving average 200 even more smoothens the curve here, or the price chart. And we could also say that the simple moving average 50 captures more recent price trends and reacts faster to changing prices and changing trends than the SMA 200. So for instance, here in the COVID-19 crisis, the SMA 50 falls faster than the SMA 200 because it only takes into account the most recent 50 days. And finally, we can observe some points where both curves cross, like here, for example, or here. And that's the so-called moving averages crossovers. And we will build our strategy based on these crossovers. And that's exactly what we're going to do in the next lecture. So thanks for watching and see you there. Bye. All right, first of all, let's drop all missing values in df. And essentially, we are starting 200 days later at the 19th of October 2010. So that's the starting date where we have the SMA 50 and also the SMA 200. I said before that the SME crossover strategy is a momentum strategy, and the rules are pretty simple. So the shorter moving average, in our example, the SMA 50, captures the most recent price trends. And technical traders assume or argue that the most recent price trends will persist also in the near future. And whenever the SMA 50 crosses above a moving average with a longer window, for instance, the SMA 200, then this is a signal to buy or to go long, because the most recent trend, rising prices, will persist in the near future. And in contrast to that, whenever the SMA 50 crosses below the SMA 200, this is a signal to sell or to go short, because the most recent trend, falling prices, will persist in the near future. And again, we are comparing our SMA crossover momentum strategy with buy and hold. And we actually have the position +1 for investing whenever the SMA 50 is greater than the SMA 200. And we have a short selling position -1 whenever the SMA 50 is lower than the SMA 200. So coding wise, we subtract the SMA 200 from the SMA 50, and we determine the sign. So whether this is positive or negative. And if this is positive, then the position is 1. And if this is negative, the position is -1. And we create the additional column position. And let's have a look here. And for instance, on the 19th of October 2010, the SMA 50 is greater than the SMA 200. And therefore, the position for the next day is +1, and so on. And we can also intuitively visualize this with the following plot. So we plot the SMA 50, the SMA 200, and our position. And we actually create a secondary y-axis for the position, because the position has a different scale between -1 and 1. So let's simply have a look here. And again, in blue and in green, we have SMA 50 and SMA 200. And in red, we have the position. And the position is either -1 or +1. And the position changes whenever both curves cross. So essentially, here we are starting with an SMA 50 that is greater than the SMA 200, and therefore the position is +1. Then the curves cross here, and 50 is lower than 200, and therefore we have the position -1, and so on. Next, let's also determine the daily returns of our strategy and the prices, and this is nothing new. So these are the daily returns, and so now let's calculate the prices. And finally, let's compare buy and hold and our SMA crossover momentum strategy. And in blue, we have here buy and hold, and in green, our strategy. And obviously, our strategy clearly underperforms buy and hold. At least this holds true for a longer time period, like here we have 10 years. But for some shorter periods, like here, maybe that's only days or weeks, the strategy overperforms the index. But apparently this is only a short time frame. And finally, let's also calculate annualized risk and return. And buy and hold has 8.7% annualized return, and our strategy -2.2%. So we couldn't find any evidence that a simple moving averages crossover momentum strategy over or outperforms buy and hold. And for the sake of completeness, we can also test the corresponding contrarian strategy. So whenever SMA 50 is above SMA 200, then we take the short position and we simply change the sign here. So here we have minus. And let's also visualize here. So now we have here on each and every timestamp the opposite positions. And let's also calculate returns and also the prices for our strategy, and let's compare. And also here it's pretty obvious that the contrarian strategy underperforms buy and hold. And we can also see this here with annualized risk and return. So our conclusion is pretty clear. We shouldn't rely on simple moving averages strategies, at least those simple ones. And with this, we have reached the end of this video and hope to see you also in the next one. Bye. Alright, this last lecture is a fun lecture, and let's assume that we can perfectly predict the future. So in the morning of each trading day, we can predict whether the Dow Jones Index will rise or fall on that day, and take the appropriate position. So that's the perfect strategy, and let's backtest that strategy. And again, we are restoring DF. And again, let's define for each and every trading day whether the return is positive or negative, and let's create the column position. So this is nothing new. Now for our simple momentum strategy, we had the following situation. So for instance, on the 5th of January 2010, the daily return was negative, and therefore on the next day we take the position -1. And that's actually the reason why we used here the shift method to calculate the return of the strategy. But now we're able to predict a day's return in the morning. So we can define the position in the morning and take that position for that day. And therefore we simply delete here the shift method. So that's the only thing that we have to change here in our code. But this will completely change the result here of our strategy, and we will see this in a minute. So let's define the strategy here. And on each and every day here, we have a positive return for our strategy. So for instance, in the first day, the Dow Jones Index falls, but consequently, we take here a short position. Then on the next day, we have a positive return, and we take the long position, and so on. And let's finally calculate the prices for our strategy, and let's visualize our strategy. And it's no surprise that our perfect strategy completely overperforms or outperforms buy and hold. And obviously here we are on a completely different scale, and therefore we should enable a logarithmic y-axis. And we can do this with the parameter log y equals true. So the default parameter is false. And still the scale is pretty different, but it's no surprise as we end up here in our strategy in the billions actually. And let's also calculate annualized returns. And here we end up with an annualized return of 166%. And actually our investment is steadily increasing, so there's no single day where we have actually a negative return. So for those who can perfectly predict the future, it's no problem to become a billionaire. But of course, this is only wishful thinking. Alright, thanks for watching, and see you in the next project. Bye.